Hello! So this week we are going to do an experiment on diffraction. Basically, your setup will look like this. You have the optical bench on the table, you have the laser here, viewing screen, the line camera that will be used to record the intensity of the light going through these slits that are here mounted on this translator. So the first part of the experiment is going to be a qualitative experiment. We are going to look at the width of the central diffraction peak for different slits that we are using in these labs. So we are using the slit of 0.02 millimeters, 0.04, 0.08, and 0.16. It is important to remember that slits are here on this silver part, and then labels are not aligned with the slits. So if you look from behind through these slits, you will see where their positions are. For example, here is the 0.16, here is 0.08, 0.04, and 0.02 millimeters. So the first part of this experiment is done in the dark. I will show you how to set up, and then I will turn the lights on to collect the data. So what do you want to have? You want to have this edge of the laser here aligned with the zero line on this ruler here, or in this case from this side when you look it's going to be for a 1000 millimeters line. You're going to turn the laser on, and then you're going to place this viewing screen here on the center, and then align the laser so the laser light here hits the center of this screen. Then you're going to place the slits 200 millimeters away from the laser light. So you want this slit here, middle of this component here, to align with 200 millimeters away from the laser light, and then you will put a viewing screen 500 millimeters or further away from the slits. Okay, so important thing here to remember is once you align the laser light to go along the center of this optical bench, you're not supposed to move the bench around. So now we are going to put slits here 200 millimeters away from the laser light, and then we are going to put viewing screen 500 millimeters away from the slits. Now I will go ahead and turn off the lights to show you how to record the data. Okay, so well, now you don't see anything. So what we will do, we will turn this micrometer until we are sure that the light from this laser is going through a slit. So in our case here, what we see is the light going through a 0.16 millimeters. You only see the central diffraction peak, and then you will use the ruler on the viewing screen to measure the width of this central diffraction peak. Okay, let me move to something a little bit more different so you can see. Okay, so here we are going through 0.08. You're gonna have a central diffraction peak. That's the only thing that you see here on camera, and then you will see on your viewing screen the secondary maxima that you will count, and then if you count secondary maxima on one side of the screen, you can just multiply them by 2 and then record that value. Okay, let me move on to 0.04 or 0.02. So maybe then you will be able to see. Alright, so this is 0.04. You can see here the one that's disappearing. That's the central diffraction peak, and then maybe And then here now finally on my camera you are able to see the secondary maxima that you will count, and then you will measure the width of this central diffraction peak. Okay, so let me turn the lights on and see, maybe we can see this with the lights on. As you can see, it's really hard. You can only see here a central diffraction peak. You can measure the width of it, and then you will count this secondary maxima. Okay, so once you go through all of these slits and record the width of the central diffraction peak and count the number of secondary maxima that you can observe on the white screen here, that's enough. We are going to use the computer to collect the intensity profiles for these central diffraction peaks, and then use the theoretical equation to actually calculate the width of this central diffraction peak. Okay, so now we're going to move on to the second part of the experiment. We will remove this viewing screen and then position the camera on the optical bench. We will use this camera to record the intensity profiles of these central diffraction peaks, and then we will use the theoretical equation to calculate the width of this central diffraction peak. So in the first part, I'm going to show you how to collect the data, all the profiles, and then I will record the screen of the computer to show you how to analyze the data and print the graphs. So first, your TA will assign you the distance from the slit to the camera lens. Please note that this base here is just a base, don't worry about it. So this edge of the camera here is where the lens is. So this edge should align with a number representing the distance from the slits to the camera. As I said, your TA will assign you this value. So for the purposes of recording this video, I'm going to place the camera here. Camera is connected to the computer. Once you log into the camera account on the computer, you're going to double click here on this CCDC camera. This window will open up. You need to uncheck this box here where it says protect my computer and data from unauthorized program activity. Uncheck here and then click OK. Then this is the window for device selection. You just need to click OK here, don't click anything else. So the next step before we start recording the data is to set up this software. We are going to maximize the window. The next step is to change the average frame count to 10. Okay, then exposure time, maximum exposure time is going to be 10 milliseconds, and then exposure time here is going to be 0.1 millisecond. We strongly urge you to collect all your data to desktop. So here where it says file control, you're going to click here, choose desktop, click OK, and then file name, you're going to change the name of the file every time you record the data. Usually we suggest you name your file by the size of the slit. For example, if you're going to record the data first for 0.02 millimeters, I will just type 0.002 millimeter slit. Then we are going to, for the graph type, we are going to select here raw line data, and then we will show the real-time spectrum. Lastly, you're going to click here on this blue arrow, and this will help you to observe the live data on your screen. This line here represents the live data from the intensity of the light recorded by the camera, and this is basically just intensity of the light from the room. Finally, you are done setting up this program and you're ready to collect the data. Once you're ready to collect the data, you will just click here on this grab frame icon, and then your data with the file name that you gave in this box here will be saved on the desktop. I will briefly show you how the file name given here in this box will show up on your screen once you click here to collect and grab the frame. So if we click here, we name the file 002 millimeters. Now once you minimize the screen for the camera, you will see on your desktop 002 millimeters _ 0. This is the data that you collected for this intensity profile. Okay, next I will show you how to align the laser beam with the camera lens, and then how to record the intensity profiles for 4 different slits. And furthermore, we will move on to a data analysis for the intensity profiles that you collected on your desktop. Okay, so first thing you have to do is you have to remove the slits from here. Then you have to make sure that the laser light is hitting the center of the camera lens here. On your optical bench, you have these screws that you can use to level the laser light. You want to make sure that your laser is centered. Okay, I know this doesn't look good, but let me show you. In order to see and to make sure that the light is hitting the center of the camera, you will see how this blue light will start changing in a second. So you want a profile like this. So you want a profile that's wide like this and centered around 1800 points here. So once you have this done, you're going to return the slits on the bench and make sure that they are 200 millimeters away from the laser light. Okay, so now I'm going to show you how to record the data for a couple of these slits. So first one is we want to go through a 0.02 millimeter slit. So this slit is super wide, and then intensity profile for this slit may not look pretty. So basically what you will have to do is you will have to increase the exposure time. You see how with increasing the exposure time, how I can change my intensity profile. Your lab manual told you to set the exposure time to 0.1 millisecond, but for the small slits of 0.02 millimeters and 0.04 millimeters, you will have to increase the intensity profiles. So once you have this intensity profile and you're satisfied with it, you're going to change the file name to 0.02 millimeters and then click on the grab frame to record the data on the desktop. So once you're done with this, you're going to move on to the next one. Next one is 0.04 millimeters. You want to look on the back of this slits to make sure that your light is going through the slit, and you also are seeing on the screen here when the light is going through the slit. So the one thing you have to do here is reduce the exposure time, because you need to make sure that the whole intensity profile is on the screen. So these impurities here that you see, you should see the nice and straight line, but these are the actual interference from the microscope glass that's used to keep these slits together. And this is something that we cannot fix, so just keep ignoring it. So once you're satisfied with this profile, you're going to make sure you don't move the table or anything, change the file name to 0.04 millimeters and then grab the frame. Then you're going to move on to the next one, 0.08 millimeters. You see now the light is not going through the slits at all, and here we are. Again, you need to reduce the exposure time because you want to make sure that you have the whole intensity profile on the screen. So once you're satisfied with this intensity profile, you're going to change the file name to 0.08 millimeters and then save it by clicking on the grab frame. And then lastly, you're going to move to a 0.16 millimeters. Here we are. It looks pretty. You're going to reduce the exposure time. And then if you're happy with your intensity profile, you're going to change the file name to 0.16 millimeters and then record it on the desktop. Once you're done recording the data, you can close this program. And then next step is to analyze this data using the instructions given in your laboratory manual. Once you're done collecting the data for intensity profiles for all of the 4 slits provided in the lab, you should obtain the 4 different files on your desktop. If you follow the convention we suggested in this video or the convention suggested by your TA, the files should be named 0.02 millimeters and so on up to 0.16 millimeters. Okay, so now you're going to follow the instructions in your laboratory manual to analyze these data and to find the widths of the central diffraction peaks for each of these intensity profiles. First, your laboratory manual suggests you open one of these files to make sure that it contains the data. Neglect that, there is no need to open the files. We already know they are here and they contain the data. Next, your laboratory manual will give you detailed instructions how to analyze one of these intensity profiles. I am going to show you how to analyze the first intensity profile using the Logger Pro, and then how to add the other 3 intensity profiles and really fast and accurate do the data analysis for all the data that you collected. So first you're going to open the Logger Pro by double-clicking on this icon here. Okay, next you're going to insert your data. You're going to click on File, Import From, and then Text File. Make sure you have selected Desktop here. And in order to see your files, you need to select all types of the files. So click here, All Files. Then you will see here the data collected. Let's click on the first one, 0.02 millimeter slit. Click on Open. And then you will have the intensities in this column here. So next we are going to rename this column by clicking here, right click, choose column options, and then choose this column for 0.02 millimeter slit. We are going to change the name and the short name to intensity here. And then click Done. You see that the name here changed to intensity. Next, we want to create a column for the number of pixels. We are going to click here on Data, select New Manual Column, change the name and the short name to Pixel, and then generate the values from 1 to 3648 with increments of 1. And then click on Done. So the camera sensor is actually a linear array that consists of 3648 pixels separated by a distance of 0.008 millimeters. Next step is to create a new column for the position of the array. We are going to click here on Data and then click on New Calculated Column. Change the name and the short name to Y. Units are going to be millimeters. And then to calculate Y, we are going to multiply pixels by separation between each pixel. So here we are going to type open quotation, type pixel, close quotation, and then times 0.008. Make sure that if you named this column here pixel with lowercase p, you have to use the same word here with the same letters, so pixel with a lowercase p. Okay, then click on Done, and now you can see this column here that represents the position of the array. Okay, so now you have the intensity, data. You also have a position of the array data. You need to plot a graph of the intensity versus Y. To plot a graph, you're going to click here on Insert and then select Graph. Then you're going to adjust the size of this graph by enlarging it like this. And you want intensity versus Y. And then you're going to click here on this letter A to scale the graph to fit the data. Okay, so basically this graph here represents the intensity profile for the 0.02 millimeter slit. And then this distance from here to here represents the width of the central diffraction peak in the intensity profile that you recorded. Okay, we need to do a little bit of more cosmetics here. You're going to right click on the graph, select the graph options. For the title of the graph, you're going to name it with width of the slit that you used, 0.02 millimeters, and then type your names, yours and your lab partners. You want to do this so you know when the graph comes out of printer, you know that it belongs to you. And the next thing you're going to do is you're going to click here on Connect Points and then click Done. So now when you print your graph, it will come out with the intensity profile for the desired slit and with your names. So if you bring your mouse down here, in the lower left corner, the first number is going to represent Y-1. And then if you bring your mouse here, the first number in the lower left corner is going to represent Y-2. The difference between this value and this value for the Y will give you the delta Y. It is a width of the central diffraction peak. You will record these two values to your lab manual into the table, and then you will calculate delta Y simply by subtracting two of them. And then you're going to use the theoretical equation to calculate the value for delta Y theoretically and then compare your theoretical and experimental data. Okay, so once you're done recording the data to your table, you want to print this graph. Simply you're going to click here on File, Print Graph. Just click OK here, don't change anything, and then choose you want to print copy for each member of your group, and then click OK and the graph will come out. Okay, so now instead of to close this program and start all over again, analyzing the intensity profiles for the additional 3 slits you used in this experiment, I will show you how to continue from here and easily and accurately analyze the data by skipping a couple of steps. So first you need to remember that your Y here and pixels, they're not going to change. The camera is always going to have 3648 pixels, and the distance between each pixel is going to be 0.008 millimeters. So the only thing that's going to change is the intensity for each of these slits. Okay, so now we are going to go ahead and import the data for 0.04 millimeter slit. Click on File, Import from, Text File. Make sure you choose the desktop and then All Files. Click on 0.04 millimeters and then click on Open. Notice here that this new column has green numbers. So you're going to right click here, click on the column options, and then choose 0.04 millimeters column. Change the name and short name to intensity. And now this is really important. You're going to click here on options. For the style here, you're going to choose none. And then for the color here, you're going to choose black and then click done. We did this because we want all the intensity profiles to be represented with black color, like the first one that we did. Okay. So now we have our intensity for the second profile. We have the position of the array, Y here, that didn't change. So now the only thing left to do is to plot intensity versus Y for the 0.04 millimeter slit. You're going to right click on the graph here and then select Graph Options. First, you're going to change the title of the graph. Now it's going to be 0.04 millimeters. Then you're going to click here on the axis options and then uncheck intensity for 0.02 millimeters and then expand 0.04 millimeters and then check intensity here. This means that you want to plot intensity for 0.04 millimeter slit versus Y. Then click on Done. And here we are, the intensity profile for 0.04 millimeter slit. Then again, you're going to bring the mouse here, record Y-min1, Y-min2, calculate delta Y experimentally, and calculate delta Y theoretically, and then compare the two values. Okay, now the last step to do is to print this. Click on Print Graph, click OK, and then print 2 copies, one for each group member. Okay, so now from here it's easy to proceed. You can import the data for 0.08 millimeters, repeat the same steps like we did for 0.04 millimeters, and then finally import the data for 0.016 millimeter slit and repeat the same steps that we just did for 0.04 millimeter slit. The only thing you need to remember is to change the color of the intensity and the style, how the lines are represented, as well to change the title of your graph. I think this will cover all the information you need to know in order to successfully complete the experiment on diffraction. Once you're done plotting and printing all 4 of your graphs, you're going to close the program. Don't save anything. And then you're going to select the data and delete all the data that you recorded, and then you're going to empty recycle bin. Lastly, you're going to log out of the camera account on your computer. That's it for this week. Thank you.